Hello and welcome to AUTOMAT Live-Coding. I will show you two versions of AUTOMAT. So this is the old one. So this is one what we had a couple of weeks ago, before we started our current adventure into new rendering territory. I don't think this one uses textures. Or maybe it does, but it's not doing anything weird with them. Anyway, this version of AUTOMAT almost works. It has some bugs, but not that many really. So since then, we decided to improve the latency of AUTOMAT. So this version that you can see on the left, we actually measured the reliability of event delivery of macro playback coming from this version. And the numbers that we got, those were the numbers that we got. So first of all, there was jitter. So events were sometimes delivered faster, sometimes slower. And the amount of jitter was about 30 to 40 something milliseconds. We also had an issue with drift. So for every second, AUTOMAT actually thought that more time has passed. I'm not quite sure why this happened, but yeah, the drift was about one frame, about 16 to 20 something milliseconds. So since then, we split the rendering from AUTOMAT's logic. So instead of having a single dedicated thread where everything happens, which simplifies a lot of things, single-threaded, it's just like JavaScript. We went in the direction of having a quote-unquote free-threading object implementation. So essentially this means that each object has its own mutex. It can be used concurrently from any thread, and if you have 20 objects and they are all running, they could all run on different CPU threads, so without blocking each other. Widgets in this new implementation live in a separate thread dedicated to widgets, so all widgets are still on a single thread, they don't need any locking, but they do not interfere with event delivery. They do not interfere with AUTOMAT execution. This is a big refactoring which is still in progress. As you can see here, we have plenty of debug layers, so this rainbow line around object, it's updated every time the object is re-rendered. So the one on the top that you can see, this is the window being refreshed. The window is refreshed very, very fast, so we get something like 2000 frames per second here. It's not fast as here, but decent. Next, around every object, you also have those frames, which are also updating only when the object updates. In the lower left corner, you can see those numbers. They indicate how long it takes to render the texture for this object. And this number is updated generally whenever the object is re-rendered. We are using a moving average, so if there is a sudden slowdown on a machine, the render times will increase and those numbers will reflect that. Okay. Now, on this new version, we also executed our benchmark, and the numbers are like an order, maybe not an order of magnitude. So we still have jitter, which is around one frame. We will have to bring this down. Like this is super important. It cannot be at 16 milliseconds, because 16 milliseconds is the length of a typical frame like in a normal game. So here we would have desync issues all the time. We would want to have less than 1 millisecond in the jitter category. But it's way better than it was. And the drift disappeared almost completely. I don't know where drift was coming from, but it's nice that it's gone. We don't have to investigate anything. There is still maybe a little bit of drift. We will look into this, maybe, eventually. So, the new version is seriously broken. The objects, they think they are being rendered at position 0, 0. I know why. It's something we can, I think, fix easily. Oh yeah, look. The connection shows the outline of the object here, but I have to point to the actual object to connect. We will fix that. Okay. And we are using cursor now. So bye-bye VS Code. Cursor is really good for refactoring. So when I was offline for the past couple days, like since Friday, I actually went ahead and implemented just a bunch of CLs. So the number of commits that we have here, 33, I think I've submitted I think I created 5 new commits. Cleanups, like lots of to-dos that we had in the background are now fixed. Cool. Also, there is mass exodus of developers and generally people from Twitter to Blue Sky, and I have a Blue Sky account, and I intend to actually write some bots for the live stream on Blue Sky. So this is my nickname. And I think we will have something like live automat.org on Blue Sky. And this is going to be the bot that's going to be posting updates, about the stream happening. And I think maybe even like responding to this bot will trigger a notification on stream. Something like that.
Wantonimity 8 says,
"What's up, man? How is it going?"
Hey. So I was looking at how to integrate with Blue Sky, and the developer API for this is... So first of all, I've seen intro by Alice. So Alice is a core, let's say, Blue Sky developer. I think more of an enthusiast. I don't think in the like Blue Sky employee sense. But on Alice's GitHub, you can find a bunch of Blue Sky examples. Yeah. Building things for Blue Sky. So yeah, I think I will look into writing a bot. And yeah, and we still have to integrate with Algora. I really like the new, let's say the new internet, which is slowly kind of emerging. Feels like such a nice, wholesome place. Okay, I remember why I had this file open, because this file is actually what we need if we want to change the position where we connect connections. Why is it rebuilding? Sure, that works. Okay, it doesn't rebuild everything all the time. Nice. Okay. Oh, because I added some new lines here. Okay, let's look at the code which actually draws this texture bounds. Yeah, we can start from here. Shape. Okay, so this is where we are drawing the cable. There we go, we have a 2 shape. And this is the transform that we are applying. Okay, this transform here, it's not quite necessary. So I think GUI connection widget, okay, and we fixed it. Yeah, it was that simple. I mean, not all of it. No idea what's going on here. We'll have to fix the dispenser logic. Some weird things happening with the dispenser. Ah, crap. When I pick objects, they just go crazy. The outlines. I think we are still drawing outlines in wrong positions. Let's ask. Just a simple question. Let's see if cursor is able to answer it. Not quite. Yeah, that would be in location pre-draw. So this is a bad answer. So this is the kind of answer that when I was like teaching at university, this is the kind of answer that people who are totally unprepared would give, just trying to improvise. So the answer should be location pre-draw. Or is it? No, that was just location draw. Okay, so this is the shape of the object. And we want to not draw this shape using local coordinates. Gray frame, we don't use that anymore. So when we draw children, our outset function, this is something we should have fixed a long time ago. Are we using this length for anything really? Or is this just pointless? Okay. I think we wanted to do something here, I don't remember exactly what. And this is one thing that we could do. It's a tiny optimization. I wanted to actually transform it.
QR Capsule Jeff, followed on Twitch.
Hey, thanks for the follow. Oh, nice. We had a whole stream where we've been like going over Hacker News comments. They were super useful, by the way. Mostly focused about the website, but still we improved the website quite a bit based on those comments.
Pepepzero says,
Hi. Saw the project on NAN.
Yeah, so since you saw the project, we didn't move really that much. At least not in terms of functionality. We are... Okay, I think I should apply the transform in reverse. I did move objects a little bit, but not where they should go. We're improving the rendering pipeline. The new rendering pipeline is kind of insane, by the way. I can show you some pictures. So essentially, I don't think like Qt or GTK do this kind of stuff. Probably web browser also do not do that, but... Or maybe web browser do this, because web browsers have layers where objects are being rendered to. But I don't think browsers are rendering stuff in parallel. So when we have a widget tree on every frame, part of the widget tree updates, and the parts of the tree which were not updated, we can still re-render using old textures. So the way it looks is, if you look closely at this, for example, macro recorder, right? It has eyes, right? And everything is sharp. When I zoom in, you can see a very quick pixelation effect. This is because, or the edges of the texture are not being, re-rendered in time. This is because we are using the texture from the last frame to render the next frame. The animation isn't always so smooth, but like the interaction, like the slowness of the animation doesn't block the whole system from working. So I can draw this object, even though it's super laggy, I can still move it around at 60 FPS. Yeah. So this is a very unconventional type of rendering infrastructure. And we kind of need something like that, because if we want to add more objects and more complicated objects.
I see huge performance benefit.
Oh yeah. And so especially so we've been doing measurements of how reliably we can play games, right? Because the point of AUTOMAT is to play games. So we've been playing Super Mario, we've been playing some other games so far, but we have some issues. There is a big drift, so for every second that passes in AUTOMAT, in real world, we have 1 second and 20-something milliseconds. Like, it varies. There is this random drift that we are trying to fix. There is a jitter, which is also caused by rendering pipeline interfering with logic. And the new rendering pipeline, which we have some preliminary measurements for, it's just much better. It's like drift is probably the most important for desync issues, and that seems to have solved itself somehow. And jitter is also down. And most importantly, we can make mistakes, because the way I'm kind of writing it, I'm not super careful about the code that I write. I'm just trying to go fast. So there is lots of bugs all over the place. This is fine, because we are changing stuff faster than the new bugs are being created. So they are kind of squashed by constant refactoring. This means we don't really have to investigate too much. Some things are broken, but they usually fix themselves as we just continue implementing other things.
Lel.
Oh, actually, let me refer that. You've just seen, so this is the copilot, cursor in action. So I just changed this transform to child into transform from child. And cursor, this is the cursor thing, not copilot thing. Cursor. It recognized that we had a 2 in the variable name and suggests we change this. So when I press tab, it renames the variables. So cursor is amazing for refactorings.
Guess I'll read more about project. Why not use Lua API of games?
We will definitely use the Lua API for games. So when it comes to controlling something, anything really, the games, each game the games are like super different. Like you cannot really take two different games and create like a common ontology that would allow you to reason in both of them. There are some games which are discrete, some of the games are continuous. The games reveal different parts of the world. Sometimes you have top-down games where you see like your environment. Sometimes you have first person. You have just so many different types of games that like a single approach for playing games would never work. So we are going for a different idea. So the idea that we are going for is to have a bunch of objects that can operate on some between each other. So objects can interact with other objects. And in addition to that, we will also have interfaces, like all sorts of interfaces that allow objects to look inside the game using all sorts of ways. Lua APIs will be one of them, but there will be also vision APIs where we can just capture screenshots and do image recognition on the game video. There will be game memory manipulation. There will be like simple image recognition where we just like monitor a region on the screen for some hard-coded, using some hard-coded classifiers. And this is another bug. Anyway. So there will be Lua, absolutely, and there will be some interpreters built into AUTOMAT. So I'm looking at two, actually, interpreters. So there will be objects like those, but this is going to be a place where you implement the logic, because typically when you want to implement like a piece of more complex logic, doing this visually by connecting cables, it's not super convenient. It's like trying to connect a bunch of patch cords. It becomes very messy. It becomes like spaghetti very quickly. So logic in AUTOMAT is actually going to be implemented not as blocks and connections, but as dedicated logic objects. And inside the logic object, you will be able to use different programming languages, whatever makes sense. So something like a prolog engine could actually live here. The one that I'm actually excited about is an assembly, like an actual assembly object. Just an object where you can build assembly programs. And those assembly programs can drive the logic, for example, control flow between other pieces of your code. Yeah, I really want to explore this assembly because it's going to be a great bragging point. If we manage to do this, it's going to be super difficult.
Cool, not sure why I prefer assembly to prolog.
Assembly is actually, I think it's easier than prolog. And probably more versatile. Prolog requires a very special kind of training. It requires somebody to finish formal education, to know about how logic works, right? And this is not the case for actually most of the people. And I think Prolog also is bad at exploiting the Prolog doesn't really unlock the true power of your computer in the same way that assembly does. If you implement stuff in assembly, it's very, I think, empowering to people. And I think if we can create an environment where somebody who's totally non-technical, who doesn't know how to like even use computers, like very much, if we can create an environment where they can actually create assembly programs, I think it's going to be a very nice. I actually don't know what will happen. I think fun things may start happening if we manage to do this. So the type of assembly environment that I'm thinking is similar to human resources machine, if you know that, but with a little bit more. So human resources machine, it's still not perfect. It's drag and drop. This is nice. You have this visualization. You have nice. This is actually great. What I would also like to do is I would like to use actual assembly instructions. So there will be no fake instructions here. There will be true assembly here. And I would like to visualize the register pollution.
Yeah, or the imaginary machine. Say mix.
Yeah. So I was thinking about imaginary machine, but imaginary machine, like assembly for imaginary machine, it's, if we are doing that, we can just embed Lua or Python, right? It's going to be just as powerful. The true kind of kicker comes from using the true assembly, not a fake abstraction, not a fake wrapper around assembly. To actually, because this is a native app, right? This is not running in a web browser, so we can give you access to syscalls.
There's actor-oriented assembly based on form. U fork. That's not important for non-coders. That's cool. Challenge.
Is it not important for non-coders? I actually think this is a great way to create more coders. Because everybody starts as a non-coder, right? I think something like human resources machine that can be used by children and exposes actual machine code. I think kids will create fun stuff with this stuff, with those tools, if they can get their hands on it. Because honestly, the reason most kids are not using computers more is because most programming environments require technical education to use, like Prolog. You mentioned Prolog. It is like very natural for us to go for powerful, formally grounded tools. And they are nice, but they create this very closed ecosystem of tech people doing programming.
I agree. But if language supports pictures in a REPL, that's better than assembly. Like Racket Doll.
By the way, let me create a new page. So the titles that you're mentioning, I think it's going to be nice if we actually went through them and check them. So this is okay, I have no idea what fourth has to do with assembly or actor, but take a look. So there was ufork, rocket,
Or interactive inspectors for objects and small talk. It was advertised for children by Alan Kay itself.
Yeah. I really dislike, honestly, the way that eToys went. I think if eToys weren't aimed at children, we would use this today. That would be the way to do programming. Because eToys basically, they took Smalltalk and they took amazing ideas about how to build like a proper interface for working with computers. But instead of building like a car with this, like something that can be used by people to do stuff, they built a toy for kids. They built a tricycle. It's not... I think it's such a wasted opportunity. And I say that because I like eToys, and I think there is... those ideas are... I'm not saying this because I don't like eToys, or I don't like Smalltalk, quite the opposite. I'm saying that because I think there is a great potential there.
Glamorous toolkit is interesting. Pharaoh and a warhead.
I think I took a quick look at this. I think I've seen some presentations, yeah. Okay, but here they are doing the opposite mistake. Now they are taking the Smalltalk idea, and for some reason they are making something like IPython with this. The point about eToys wasn't the Smalltalk language. The point about eToys was that you can directly interact with visual objects, like on your screen, and those objects represent things in computer memory. And here we are like, let's forget that. Let's just focus on like creating another Python notebook based on Smalltalk this time.
Custom views for objects is GT thing.
Yeah, but it cannot look like that. No. This is... So this may be technically Smalltalk, but Smalltalk was also like just a good interface. And this interface looks like, yeah, like stuff that we have today.
There is Mondrian for graph views.
So many new terms. No. I see.
Mondrian in GTEC 12.
So my comment about this is that if we flip this around, if Glamorous Toolkit was inside Mondrian, this would work. Not the other way around, because Mondrian is like a visualizer that you can embed inside Glamorous Toolkit. And really, the point is the visualizer.
One rendering tree in GT. You can embed editors in Mondrian.
Yeah.
Or anything.
So I see that Glamorous Toolkit, I've seen some YouTube videos on this. I know they are doing a lot of work in actually making Smalltalk usable professionally. And the thing about Smalltalk was that it was not exclusively about professional use. It was also just about being a good interface.
It does lack the infinite canvas-like tools.
So for instance, this thingy, Glamorous Toolkit, if you replaced Smalltalk with Python, right, that would immediately make it more successful. Because right now, anybody who wants to use Glamorous Toolkit, they need to learn. Is this Smalltalk even? Okay, I'm not sure, honestly, but
Yep.
so each tool that we use has an initial friction that we have to come through to start using this. And inventing, I don't think Smalltalk is that great of a language. The ideas in Smalltalk are good, not the language itself. And the Smalltalk ideas can be implemented in any language, really. I think using the language, the Smalltalk syntax is also probably not that great of an idea. It just increases the friction of learning the new environment. It makes people less incentivized to enter.
I lack the key bindings. Everything is too slow.
I see. So something like an editor, something like VS Code would help here, maybe.
Miss Guy.
Oh, there is a feature in chat. If you put something in asterisks, narrator would read this. Just FYI.
Next.
Yeah, so I think Glamorous Toolkit it's nice. I think it could benefit from taking less, from not taking the bad ideas from Smalltalk. Like the language is totally irrelevant, and the visualization, because okay, in Smalltalk, okay, it wasn't super pretty, it wasn't super visual, like. But man, I would honestly prefer to use interface like this one to the text-based one. Recently we've been playing Widget Workshop on stream. It's another game. I think this was inspired by Incredible Machines. And I think it may have inspired Itoi's in turn. So Widget Workshop was also aimed for kids. This was the hardest level, this one here. So I think if that was the top level interface, I mean not specifically that, but an interface where you interact with like rich, interactive, kind of living objects, they can be implemented in whatever means. No, it doesn't really matter. But the thing is, the programmer only has to connect pre-made tools together. That's the idea behind Smalltalk. And that was ufork. Oh, we fixed the outlines. Okay, let me move this out. Stuff that I've done so far. This tiny change, I will submit this. Oops. If I would to compare AUTOMAT to any existing tool, then I would actually compare this more to Bash. So this is like Bash plus Incredible Machine.
Factorio.
Speaking of Factorio, I started playing Space Age over the weekend. Member berries. It's so nice to start a new factory. Yeah, so this is the formula for AUTOMAT. The Incredible Machine game. I think this was the original one. This came before eToys. Okay, I wanted to fix more bugs. So there are 3 different bugs right now. I think if we fix them, we can actually submit this so that it can be pushed to GitHub. I'm kind of collecting those. What's that? Get rid. Why do I have this down repo? Hey. Okay. I want to finally submit all those commits that I'm collecting on my PC. And to do that, we need to fix 3 bugs. Those 3 bugs. Okay, this is actually not relevant. Okay, this is also not relevant. What we actually want to fix is dragging of objects. Dragging of objects shouldn't leave them in a corrupted state. And right now it does. When I grab an object, it just jumps somewhere and weird things start happening. And that's 1. And 2, when I try to grab an object from the toolbar, we are also crashing for some reason. Let's first work on this one. I think we're doing weird stuff in begin here. Okay, so when we construct a drag location action, we are taking ownership of a shared pointer. So this is our pointer. I think this should really be initialized here. I think this will change something, I don't know what. What's that? What's this? Huh. Okay, we should not... What's wrong? Okay. Actually need to create a copy here. Unfortunate. In terms of clearing parent, no, this is not the right way. It's a bad comment. I'm sure there is a better way to do this.
The music title.
Yep.
Kind of buggy.
And by the way, there is a website, live-automat.org, which also includes all of the music which is played on stream, and the chat. So this is the chat interface that I'm showing in the corner of the video. Aha, okay. This is probably the wrong thing. It's location within, position within location. Should I? Actually, the contact point no, the contact point is something we need to compute before we do this operation. Oh, look at that. I picked it up and it didn't jump anywhere. I cannot drag it again though. So now I can drag objects, but I can do this only once. So we have this drop location.
Saxon says.
Thank you, Saxon. Okay, so in the debug layer for widgets, I would like to this is debug rendering. So instead of printing how fast we are rendering the object, we will print how fast we are rendering, and the name of its parent. CSTR, it should be CSTR. How is it compiling?
Saxine says,
Wow, I get muted on YT. Very sad.
Yeah, so I do appreciate nice comments. It's just on stream. It's not a good place for such comments, because being TTS means that everybody is kind of forced to listen to this, and not everybody wants to listen to comments. This is a stream mostly about coding AUTOMAT.
XD.
QA Capsero says,
What are you checking?
So right now I'm trying to... There is something wrong with the widget hierarchy, because I can drag the object, I can move it around, ignore the random connection, but when I drop it down, something happens that prevents me from picking it up again. I can still pick up other objects, but then again, when I put them down, they become... It looks like they still react to mouse presses, but they cannot be picked after this happens. I was thinking that maybe I'm messing up the widget hierarchy somehow. So I added this print statement here. But this is not the case. I just need to read the code, see what am I messing up. Where do I call this from? From here. Okay, maybe I shouldn't be moving anything here. But insert should have, yeah, move overload. Let's play with debugger. Debugger will help us figure this out much faster.
Never seen C debugger before.
Yeah, debuggers are nice. The only problem is the standard library. Like the hardest part about debugging C++. Okay, so we hit this one. Let's continue. Okay, I think we should put it here.
What are we looking for?
So I just noticed that when I'm picking objects, this thing seems to work. Okay, now I was able to pick the timeline and it hit the debugger. But when I continue, okay, now I picked it up and like put it down. I cannot pick it up again. I'm clicking, nothing is happening. We are not hitting this point, but I guess we will still hit this point. Yes.
Yeah, I got the high level.
I just want to see why we are not doing that. So pointer, hover. Okay, is correct. Okay, this fails. We need to investigate the chain of parents. So when we start with p hover, so this is the timeline. From this we can go to parent, which is a location. And the location has a parent. which is a pointer. That is wrong. Why could this happen? Here we have machine drop location. Let's restart. So I can grab this, I can move this around, and I release it. We are here. Find the drop target. I said enter. What happened here? Okay, it's... So sometimes debuggers have those glitches. It was... I don't know if it's default of debugger or VS Code. To step over this line, step into the next one, step into. Okay, it doesn't want to step in.
What does call stack tell?
It's irrelevant. I'm not sure why the debugger is behaving so funny when we are at this line. Maybe it doesn't know how to handle those things. Maybe you can split this into two separate lines. Okay, step over. Now we have a drop target. Step into. Right? What the hell? I think this is the cursor fault. So cursor is this super new environment. Let's stop this. Let's close cursor. Or let's just fire VS Code. So it will be named drag action.
It's weird, but MB call stack says it's called or what?
Call stack? I mean, call stack looks fine. It's this step into that doesn't work. Okay, now I cannot drag it. If I can grab this one and drop it. So first we are here, and then we are entering this function. Okay, this is some weirdness of... Actually, I have no idea what's that. But okay, so we have a location. And that location has a parent. Sorry, what? I see, okay, okay. This is my issue. I screwed up because
That parent here is the issue.
no, because within each object we have this field, which is parent location. So location is kind of like a variable. It's just a place where we can attach objects. It holds generic stuff. But we also have widgets, and widgets also have parents. So there is shadowing here. I think if we rename this to parent location, the issue becomes obvious. And same here actually. And that line was actually fine.
Shadowing. If only you could hover over fields and see what class they're inherited from.
I think I can. Right? Okay, it's better. Way better. We fixed one of the issues. I'm just double checking if everything that we are doing makes sense.
Time to go. Happy bug is fixed.
Thanks.
Atheno just followed on Twitch.
Oh, hey Atheno. Thanks for the follow. Okay, so now what I want to do is when I drag objects, the location is totally messed up. This is what I want to fix now. Oh, look, it's almost correct now. Almost. Yeah, we are missing some transforms somewhere. Blah blah blah, pre-draw, irrelevant. So this is where we are playing with transforms, from shape to shape. I think we can remove the to and from. That may help. Nope. Okay, let's actually think about what we are doing. So connection widget in terms of hierarchy you know what, you would like to add a new debugging API. So when we have a tree of widgets, yeah. We need to print this tree. I guess from the root. First we need to calculate indent. Okay, this is actually a good one. see. I'm using nerd font in my terminal. There should be Finder. Okay, this is what I want. Light vertical line. This indent, let's skip this. I think a proper rendering of this tree would require some deeper analysis. pre and post order numbers would be necessary here to draw those lines correctly. We would want to draw those two, but not those three. Anyway, I will add the names for some widgets. Actually, in the default implementation, can I get the name? I have a name. It's funny how ordering is implemented. Okay, Boost has some demangling utilities. I don't want to pull another dependency. Look at that, it just calls CXID mangle. Okay, it has to be mallocked. Yeah, actually, you can just use zero termination here. Sorry. Nice. I mean, we shouldn't see widgets here. We want the concrete type. I wonder why the previous version worked, the new one does not. Let's revert this change. Right, we don't have any widgets here. I mean, not just widgets. I don't know how to guarantee the name is going to stay alive. Should I just create a field? Why not? Cool. Okay, we can see the tree of widgets. Nice. So this is what I wanted to see. So connection widgets are actually attached directly to the window. That was a lengthy escapade, but we have a better debugging tool now. The names of objects are finally cleaner. So what I am doing is I am taking two points and transforming this up to parent machine, which is actually wrong because the connection widget is attached at the window. Okay, so the target position is now correct. I think this should be enough. Matrices. I think I figured out finally how to work with them. Or maybe I didn't. From point, I think is wrong now. From shape here. Okay, from position still isn't perfect. Okay, and this start isn't... Who's using this actually? I think we could benefit from a better transform function. So in this place where we were asking for the start position of an argument, we cannot really compute the start position in the parent machine when the object is dragged, because a dragged object is not attached below the parent machine widget, so this should actually error out. There should be an error here. But I'm thinking that we could actually have a function that would help here. The thing is, we would skip this down and up. It's a big change. But let's say we can do this. And right now, the way we can do this is that first we will do this, and then do that. It's not optimal. From those functions we need to remove two. From this we remove from. Now, argument start function. I think this should be a reference. Okay, I will fix this later. Okay, now all the from positions are wrong, but we'll fix this. At least they are consistently wrong. The wrongness doesn't change when we grab an object. So that's nice. So this is the coordinate of the argument start position in the parent machine. Okay, here we are checking the overlap. Very weird.
Knight says,
Hey everyone.
Hey, Knight. Okay, 2 points. We are doing something good with 2 points. Is this going to break it? Yes. Okay, there is a bug in transform between. First we want to call transform up. And then transform down on the second. This doesn't make sense, I'm just trying random things. Yeah, that fixes it. Okay, the connections look better now. Now I would like to fix this shadow. Some weird things here. This is super nice, this new set of transform functions. They are actually reliable. Without the debug layer, the new renderer is actually looking decent. In the 3draw function, this is where we are drawing the radar. So this is what we have to fix. Here is our routing code. Looks like the start position is good. We just need to fix those 2 points. Okay, I think doing this transform here is not a good idea. We have to fix this. So this is for auto-connecting stuff. I hope things will still work. The target position, we haven't still implemented this. We have to transform this whole array, probably, using a matrix. That should fix the thin line. should be candidate, not object. And that was the issue. Now the thin line is routed correctly. The shape of the connection is still not great. The texture is rendered in a very weird position. Okay, so let's fix the texture size. This is some unused variable. Again, we need to go to object. The next thing, which doesn't seem to be working, is that for some reason when I pick this object, the connection disappears. When I pick the connection appears. It doesn't matter how far we are. Oh, actually maybe it does. Maybe not. Okay, this connection appearance and disappearance should happen here. This should not be this should be object. Still have an issue here. So when we drag this object, it's fine. When I drag this one, not really. we need parent machine here. Yeah, strange things. Those two positions, we also have to modify them. I feel like we are slowly making this code readable. It may not look like that. change this. I want this loop to be similar to this one here. So this would be 2. I think the auto connection should work now. Nope. Oh, we disconnected for a moment. Strange. Let's go again here.
Mr. Fix says.
I linked to VOD archive and EIT description does not work. GitHub 404.
Thanks. I'll fix this. By the way, there is VOD archive on YouTube now. I had to migrate off YouTube because they were I kept getting copyright strikes. Yeah, this should be a live automat. Cool, should work now. Oh, actually, yeah, we should wrap this in. Something like that. Okay, we are not even getting here. Ah, I know why. Because the moment we are dragging the object, it's no longer parented to the machine. Let's just do it like that. That should work. Okay, this works fine. We can connect object when we enter the threshold. But this... what's happening here? Now it's disconnected. Okay, I think we are using wrong position. Yeah. Again, more transform issues. So this one spams the console, but this one does not. So there is a different code path active here. We need to find the other one. So this is just about rendering. Oh look, this is another place where it's invoked. It's definition. You know what, we'll fix this, but first I will make a break. Time to grab some fruit. We are slowly fixing the new rendering engine, okay. So we are still kind of on this task. Should finish this soon. There is some weird code which takes the position of the source object wrong here. But we will take care of this. So See you in an hour, roughly. Okay, that break was shorter than expected. Okay, so we want to figure out why, when we grab the object from here, we don't seem to be... First of all, we don't get those messages. And second, the connection seems to be happening in this region here, like around 0. I think it has to be in the somewhere here. Oh, I see. We actually have two pieces of code here. We only updated the first one. Here up is unused until this point. This is what we have to change. And we are replacing this. Let's see if this will work. Should work. Yeah. Easily. And this dot that stays behind the connection is interesting. I wonder why it's drawn. Even though there are no connection bounds. I think texture. Okay, I think we are in this condition. The connection is fully transparent. It should return a no texture bounds. Okay, so we are actually skipping it, but we are still drawing it. I think we should remove this span as well. So this returns null, and we are jumping here. Strange. Still, there are some weird things happening that I don't fully understand. But we fixed the auto connection widgets, so that part is done. Okay, now we have this bug with the toolbar crashing for some reason. Probably some of the parents are not initialized, that's my guess. parent is empty. Okay, so we found the action, called the begin, and then we are updating path. So I think before begin returns, the widget hierarchy should be in consistent state. So this is what we need to fix. So here we are creating the action. So when we create the action, the widget is also created, I think. Yep. And here we are updating parents. I think we should go through I will add a new function within widget. It's maybe not the best, but we need something like that. Come on. There is no such thing as children. Unfortunately, we will implement this soon. What a terrible interface. I think the next thing will be replacing these visit children with iterators. The stack traces that we are getting because we're using callbacks. This is just insane, this stack trace. It shouldn't look like that. Half of these stack traces are C++ wrappers. Then completely unnecessary nesting. And debugging has stopped. And we have to call this recursively. Isn't that nice? So from Linux main, instead of calling this, I'm going to call this. And let's put a comment on this function because it's very non-obvious. was a longer piece of text, but the toolbar should work now. Let's try to create one of everything. Initial state of connections is kind of strange. And the deletion, we broke deletion, unfortunately. Because the shared pointers, they keep the widgets alive. They are not reachable from the root window, but they have the parent pointers still. Okay, still a couple of bugs until we can truly submit this. Have crashes when closing AUTOMAT, and okay, let's fix the run button. So we still have a thread for executing AUTOMAT. Okay, there is obviously a data race here because this is executed on the UI thread. So let's see what's happening when we click the button. Or maybe not this one, because this may be a little complex. Let's look at timer. Schedule run. First of all, this should cause invalidation. So that the animation triggers. Very weird. So we can't invalidate the draw cache. This definitely is causing a redraw. Yeah, after the first press we should already see I'm removing as many objects so that we can focus on the timer. Oops. What a weird bug. I think this is something about Skia textures. I'm not doing any crazy stuff like that. So this is going to be our draw code. I wanted to run debugger. Nothing special, right? We just drawn it twice, which is fine. Now I am clicking the pusher, and the phase is set to animating, right? Let's continue. Now the phase is finished. So for some reason, draw was called twice here. I wonder why are we drawing the object second time? And third? Ignore this. Okay, I think this caused a redraw. Face is finished. Face is still finished. And then we get animating. 100 degrees should start at the correct value. That was a very tiny, subtle issue. Let's continue. Drawing, we don't care about that. Okay, now there was just one draw call when we started. Cool. So we are doing the animating. And what's that? Huh. This is strange. So let's try again. Let's continue. I'm pressing this button. And it says that animation finished. Okay, so here I'm making sure that the time isn't passing too fast. I will actually change this to 16 milliseconds to pretend like we're animating super fast. Okay, delta t is super small now. Understandable, because we reacted to the event. Yeah. Okay, so we are in the animating phase. Let's continue. Next frame. Where is it 1? I've set the limit, right? Okay, this is a different fake time. There's a fraction of a millisecond. It says finished. Ah, we are actually recording the last tick here. I think those values can be just floats. Delta time will be this, let's say 1. So we switched from 8 bytes, sorry, not, from 24 bytes to 4. Anyway, let's continue debugging. Okay. Something weird happened. The object rendered at a wrong position. And then jumped to the correct one. Interesting. We are animating. This is the first frame. Now this is the second frame. It should be 16 milliseconds and we're still animating. Let's disable this breakpoint. Okay. I guess we fixed something. Okay, so this works, but why is it Oh yeah, we removed this. Let's make it that fast. Cool. This looks good. Let's now go back to our scheduling function. Schedule run. We'll just follow debugger now. I rarely do this, but it's a nice way to follow the execution, as opposed to clicking F12. Let's set this always on top. There we are. Let's enter. So we are creating a new run task. Okay. We're going in the schedule. Okay, so we are adding this to the queue. Okay, I know what's the issue. We are adding this to the queue, but the other thread is actually sleeping. Okay. I'll be right back. Okay. So, I remember that my plan was to actually create like two ways of running work in AUTOMAT. One would be based on directly executing the next task immediately. So when you finish your current action, this actually is executed on the UI thread. But AUTOMAT could actually borrow UI thread and execute on the UI thread. That's not an issue. So but let's say this schedule run is actually going to use a concurrent queue. So let's change our queue to a concurrent. That should basically make everything work. And then we will let's just make it concurrent queue for now. I think I could remove this queue from here. And also from base, I think it should be part of tasks.cc. And there is a bunch of issues here, and there will be more once we remove the queue. Schedule should kind of take the ownership from the object. So there is a memory leak here. Now, I think run loop should move it from base to tasks. Also events, we don't need the events anymore. We don't need to check for emptiness. This is check for emptiness. This is old code, ancient code, really. Yeah, I don't care about those things. I think we need to get rid of the events. Now we are communicating using the queue. I mean, can we communicate using the queue? Can we block on it? Let me see. We cannot. Okay, so we need the events. We cannot remove them. This is good. We need to somehow wake the main thread. or not main thread. We need to notify one of those threads, run thread. So if we go to the schedule function, it should be somewhere here. I think this run thread should be moved over. This is the only place where it's used. It doesn't even need to be exported. Okay, this is actually a wrong place to invoke it. Should be invoked from here. in those events, they aren't actually used a lot. Basically timer thread and this. And we're going to replace events with condition variable, I think. I think all of that should really be moved to tasks. Let's do that. Or maybe okay. I will have to think about task ownership, like what to do with it, when to pass it around, and what not. Okay, so this is how we schedule stuff now. Now that we don't have events, okay, we use this a lot. It doesn't matter. We do not need this stop callback. Or actually, no, we do. So here is the thing. We need to create a condition variable. and a mutex. When we initialize everything, I think okay. We are running the loop, and when the loop is finished, here we will do this, oops, lock. Again. Okay. VS Code is having issues. It's time to say goodbye to VS Code. Let's try cursor. Okay, this stop token, this is the variable that we have that is actually protected by this condition variable. And this auto-delete task wrapper, we may need it, I'm not sure, honestly. I think the task needs to delete itself, but I think they do this, usually. So we do the request stop. Okay, notification can be done afterwards. Now we don't need this. Is function task deleting itself? No, it's not. I think it should. Shadow task can go away. So generally, every task should delete itself unless it really wants to kind of stay alive like this run task. And this is the only exception. We actually handle these differently. Let's go to task schedule. Here we should notify one of the threads which are waiting. This is kind of weird. Why do we log the mutex here? I think this loop needs to be restructured a little bit. So imagine this scenario, we are running the loop is running, and then loop is finishing, so it's here. And then we are adding another task to the queue, and we are notifying one of the threads by calling this notify one AUTOMAT thread. This is a run loop. I would like to move it. Or maybe not. The thing is, there is this queue here. So after I log this variable, I would like to check if the queue is empty. Can I even do that? I think we should do another dequeue and try to dequeue another element from the queue while holding the lock. And if we manage to do that, then we should continue. This is used extensively by tests, but otherwise it's kind of internal. Okay, I think one thing that we can do in pre-execute is to set scheduled to false. So if we cannot take a task, then we will do a log. Then we will try to dequeue again. And then we will wait. And after we are woken up, we will start from the start. Simple enough. This should be part of tasks.hh. Same here. Okay. I think this should be part of pre-execute and post-execute. Actually, it already is. About this no scheduling, I think no scheduling guard should clear this. So we may not need that. It's running. And it crashed. But that's nice. It actually was executing for quite a bit. And do other things work? Can I still... What's that? Why is it missing? Really? Oh, okay. Ah, this wasn't initialized, okay. I guess let's see what happens when the timer finishes running. Yeah, it runs and then crash. Debugger will tell us what's happening. Okay, we should probably figure out how we want to manage tasks. What's the ownership story for them? Doing schedule run. Doing NQ, blah blah blah. Somewhere here should be on run. So what we are doing here, we are locking the mutex and we are leaving a new task in the queue. Timer finished task. Looks fine. So this is our timer thread. Timer thread waits until we wake. No, this is a bunch of unique pointers. Anyway, we are moving them to ready tasks. Okay, I think we are accidentally deleting the task. How it used to work. So when we are doing a move, it's actually not clearing the pointer. That should fix it. It worked. Wasn't that nice? Huh. There is a data race, I think, still. The way we manage the task is just terrible. I like how grabbing this very quickly causes the shadow to stay behind.
Low pass effect.
Nice. Can you hear? It's still ticking. We didn't delete it properly. But okay, I think we finished the next point on the list, which was to fix the run button. I think other objects should also start working now. Let's try to record the macro. Okay, maybe not. I think this is something that we can already submit. It's not bad. So we moved a lot of code from base.cc, which is nice. This is kind of obsolete. Largely, base.cc is mostly code for the machine. I think this run loop should be met with a run thread. They are very similar.
Says, hello Owen, this is a reminder that TTS only works in English.
That's true. I'm thinking, do I need to lock the mutex here? So if I try to DQ here and it fails, and we lock this mutex.
Erwin says,
Oops, sorry.
I think it's possible that one thread tries this DQ twice, then we are doing NQ and notifying the thread, and only then we are waiting here. So it's possible that there could be a not date trace, it's a threading issue, it's not a common threading issue, it doesn't have a name. Basically, we just need to establish a lock. Should work. Let's see if this still works. Okay, seems to work. I was worried there could be a new deadlock now, but yeah, this is fine. How do I call this change? Fix concurrent task. I'm not sure it's fixed, but this is something we can commit. I mean, if we can fix those 3 more bugs, then I think we could push this to GitHub and release a new version. Oh, and I would also have to make this work on Windows. Because we're in a happy Linux land still. And yeah. This pack frame, it has to be moved into some separate function so that it can be used on both platforms. Should we start the next one? Actually, there was Kekpip mentioned those two systems. I think I'm kind of drained when it comes to programming for today, but I could still look at those things. ufork. Ufork sounds just crazy. So this is actor-oriented assembly, which those two things are actually, they go hand in hand very well together. Assembly is very good for creating state machines. If you can kind of present your program as a bunch of machines that are sending messages to one another, doing those things in assembly is very natural. But there is also Forth, and Forth is a stack-based programming language. Like, it is very stack-based. It's more like, it's not like just regular stack. It's like in Forth, you do everything by pushing stuff to stack and doing operations on the stack. I'm not sure if instruction level concurrency is a good thing or a bad thing. Does it mean every instruction locks? Let's check this out. Astarian is good. Okay, this may be loud. Let's see. Okay, let's listen to this.
Contemporary microprocessor designs are based on pervasively shared, mutable state. This introduces numerous vulnerabilities that have been exploited to violate the security of our computing platform. Mechanisms to mitigate these hazards, such as memory management units, MUs, increase the complexity and power consumption of CPUs. The movement to multi-core processors amplifies the problem and adds more complexity to synchronize shared memory access across cores, e.g. cache coherency. By focusing on memory safety from the beginning, we can greatly simplify microprocessor designs using less logic and consuming less power. The key is moving away from shared mutable state. One way to do that is to prefer immutable data and stateless computation, as is done in pure functional programming. Another way is to exclusively use private mutable state. Both techniques can be used in a complementary manner to achieve provable memory safety.
Makes sense. This is how you build electronics, right? You don't have... You have like
Nearly all contemporary
a couple like sequential data processing steps. There is no shared data, there is no locking
Nearly
issues.
all contemporary processor designs evolved from the von Neumann architecture, which originally specified a single processing unit with a local memory and connections to external I/O devices. The processor executed instructions sequentially, performing I/O, calculating values, and mutating local storage. This design is fine if you only have one thing to do. However, the design soon evolved to support multitasking, which gave the illusion of multiple independent processes by multiplexing the processor core. Unfortunately, from the perspective of the processor, there is still only one thread of control, focused on the currently executing instruction sequence. A software process abstraction required additional hardware to support the separation of resources used by each process to prevent them from interfering with each other. However, it was also desirable for processes to communicate with each other, which they usually did through access to shared memory. So, a limited form of interference was explicitly permitted. Increasingly complex hardware was designed to help address the hazards caused by this model of shared mutable state among independent processes. In an attempt to improve performance, multi-core systems were introduced. Rather than multiplexing a large number of processes onto a single core, multiple cores were available to execute processes in parallel one. The downside of this approach was an increase in the potential hazards of sharing mutable state. This led to even more complex hardware.
I think this is just repeating the same thing over and over.
Among the processor cores.
It's all introduction still.
The data representing the state of a computation can be accessed safely by making it either immutable or non-shared. If data is immutable, read-only, it can be safely shared among multiple processes. Even if it is accessed concurrently, there is no risk of interference, because the data does not change. If data is mutable read-write, then it must not be shared. It must be owned by a single process at any given time, and cannot even be read by another process whenever there is a possibility that the owner may change it. Shared mutable state can be avoided by moving away from the load-store memory model of contemporary processors. Instead, we can design processors that use an asynchronous, event-driven model, where any mutable process state is private. By making the event data immutable, it can be safely communicated between processes. Asynchronous events provide a natural transactional boundary for private state mutation and allows ample opportunities for concurrent process. Transactional event handling can be multiplexed onto one or more processing cores without risking interference. This new model eliminates significant hardware and software complexity. No MMU is required because all memory accesses are safe by design. Cache coherency is greatly simplified since there is only one process that can cause mutation of the data it owns, and that mutation is performed in a transactional manner in response to an asynchronous event. Each core can execute instructions without interference from any other because there is no contention. And then there is no need for blocking because event generation is asynchronous. Synchronization between processes, when needed, is coordinated through events.
Yeah, I mean, this is how you design a concurrent application.
We propose a new processor architecture driven by asynchronous message events. All processing is initiated by the occurrence of a message event. An event designates a message handling target and an immutable message payload. The processor manages a queue of pending sent, but not delivered message events. When an event reaches the head of the queue, if the event target is not busy, an event handling transaction is initiated. Otherwise, the event is recycled to the tail of the queue. Message handling targets are reactive objects called actors too. Each actor maintains a behavior which defines the current message handling procedure and any private mutable state owned by the actor.
Okay, so the authors are using the term processor design. I don't think what they are doing is processor design. This is just actors. Actors sending messages to each other. This is application architecture, like one approach, like very well known. Ada does this, Erlang does this.
During an event handling transaction, the actor may send new messages, create new actors, and designate a new behavior for subsequent messages. An actor's behavior ends with either a commit, applying all transactional effects, or an abort, acting as if it never saw the event, and discarding it. An actor is busy when it is handling a message event, and
so to me, this is a red flag when somebody's using terminology which is unnecessarily complex.
becomes idle after a commit or abort. Note that an actor's private state,
And doesn't refer to prior art.
it is updated transactionally.
Like well-established terms for the same
The
thing.
transaction is aborted. Most messages are sent as part of an event handling transaction. However, your devices may also send messages. These messages take the place of device interrupts, but may carry arbitrary additional data. Messages may also be sent to I/O devices to initiate activity or administer device settings. From the perspective of the sender, an I/O device is just another actor.
Okay, there is this capability-based security. And I think I'm actually, I will look at this specific machine because this is maybe too abstract. I think maybe they are using the term processor design because they are using actor model on a far, far lower level than it is done for like software. So continuation is like a stack trace. It allows you. It's like a coroutine. Oh, coroutine is probably like the official name for that. And there are transactions here. Yeah, maybe applying something like that on a CPU level could actually produce a nicer CPU design. But I actually thought this is how already CPUs are built. There's plenty of asynchronous stuff in a CPU. Okay, so this is a highly concurrent virtual machine with some limitations, actually a lot of limitations, but does it do anything interesting? This is the question. Okay, so this is more of a research / interesting new approach. Cool. The next one is Racket. Some kind of Lisp. It's a nice Lisp UI. Okay, I think this was about this, that you can call a function and it's going to print an image. And maybe the image could be interactive. Maybe it could be like a widget. It's hard to say. Okay. I guess I will put a stop for today. The next stream, so we've spent the whole stream today fixing bugs. It's much better now, the way that Automat runs. It actually kind of runs, we can run some objects. There's a big change. Or this one. Oops. Yeah, this one also runs. We still have quite a few bugs. And weird behaviors. That rectangle here is strange. We lost the connection widget. Oh, it came back. Yeah, it's jumping like crazy. We will fix this. And I will look at all of those objects and see if they work. And if they don't, why not? They seem to work fine actually, almost. There's probably some invalidation that we, oops. Yeah, this one definitely works, it just pressed A. Yeah, still plenty of weird behaviors, and we also had this strange thing when I was like on this. Making the window smaller sometimes causes this rectangle to pop up instead of the like proper window. Okay then, so next stream we do more bug fixes. So, see ya, bye.